All right. So, all right. Now we're gonna talk about the conjugate acid base pairs concept in the Bronsted-Lowry theory, right? So, uh, in this theory, to identify the conjugate acid base pairs, the acid in the reactant side becomes the conjugate base in the product side, and the base in the reactant side becomes the conjugate acid in the product side. All right. So the first thing you need to do is identify the acid in the reactant side. Once you do that, you can easily identify the conjugate base, right? And then identify the base in the reactant side, and you can easily identify the conjugate acid, right? So you have an example here: Ha plus H2O producing H3O plus A minus. And notice here, this reaction is reversible, right? So they can react back and forth to produce reactants and products. So Ha, okay, so let's identify the acid. Once we identify the acid, it's going to be really easy to identify the conjugate base. So Ha here in the reactant side will become A minus in the product side. So what happened here? Right away you can tell an H was lost, an H was donated, a proton was donated, right? So since Ha loses its proton or it donates its H plus or proton, it's gonna be the Bronsted-Lowry acid. Right away, as soon as you find the acid in the reactant side, you're gonna go to the product side, and whatever is left from the acid is gonna be the conjugate base. So right here, this will be the conjugate base. Okay, and then H2O here becomes H3O plus after the reaction. So H2O becomes H3O plus, meaning H2O gained a proton, accepted an H plus to become H3O plus. Right, so this hydrogen here from the acid will be donated to the base, right? Will be donated to H2O to become H3O plus. So since H2O accepted the hydrogen ion, it's gonna be the base, the Bronsted-Lowry base, right? And according to this, the base in the reactants, the reactant side will become the conjugate acid in the product side. So the base here, H2O, will become the base in the reactant side. You look at the corresponding product, which is going to be H3O plus. This will be the conjugate acid, right? So the acid becomes a conjugate base, the base becomes a conjugate acid. So why do we call them conjugate acid and conjugate base? The reason is that in a reversible reaction, right? So in the forward reaction, Ha will react with H2O. Ha will donate its proton to H2O to produce H3O plus and A minus. In the reverse reaction, right? In the reverse reaction, it's going to be the opposite. The conjugate acid will donate its proton, or which is going to be one hydrogen. It will donate it to the conjugate base, or the conjugate acid will donate it to the conjugate base, which is A minus. A minus, since it's a conjugate base, will accept the proton and will form Ha. H3O plus, since it donates a proton, will become H2O, right? So they react as, so here you have an acid and a base, here you have an acid and a base. But I'm not going to ask you any questions that require you to identify or explain what happens. All the questions that I will ask you with regards to the conjugate acid base pairs is to just identify which one is the acid, which one is the conjugate acid, which one is the base, which one is the conjugate base, right? And the acid here and its conjugate base will be will be called conjugate acid base pairs. So HA and A minus are one pair, and then you have a second pair which is H2O and H3O plus. This is the second pair. You have a base and you have a conjugate acid, right? So it's a conjugate acid base pair. You have here HA, which is the acid, and A minus, which is the conjugate base. So H is going to be a conjugate acid base pair. All right. All right. So you can read this on your own, but just basically, all right. As I said, the acid. Okay, you can look at this. This is really helpful. The acid in the reactant side will become the conjugate base. The base in the reactant side will become the conjugate acid, right? All we have to do is just identify the acid in the reactant side and then find the corresponding species that comes from the acid. That will be the conjugate base. Identify the base in the reactant side and then identify the species that comes from that base. That will be our conjugate acid, right? So acid will become a base in the products, a base in the reactants will become an acid in the products. Okay, conjugate acid base pair. Right, so this is one pair, this is the first pair, and then this base and conjugate acid will be the second pair of conjugate acid base pairs. Okay, so HCl here is the acid, and then Cl minus. So since HCl is the acid, the species that comes or that is formed from HCl will be the conjugate base. So HCl is the acid, that makes Cl minus our conjugate base, right? And H3 is the base that will make an H4 plus our conjugate acid, right? Okay, so I'll give you one more example, but it's really easy once you identify the acid and base in the reactant side, because you could look at the products and easily identify the conjugate acid and base. So let's say let's see, H2SO4 plus what is it, H2O. Okay, so when these react, they will form H3O plus HSO4 minus, right? HSO4 minus, right? So you don't have to know how to do this reaction, it's not part of your curriculum, but this is just another example of a conjugate acid base pair. Okay, so right now let's identify which one is the acid, which one is the base in this reaction. Right, so we have to identify them in the reactant side, and then we will be able to easily identify the conjugate acids and bases in the product side. So you have H2SO4 right here in the reactant side. You will see in the product side is HSO4 minus. Right, so what happened here? Here it has two H's, here it only has one H, meaning it lost an hydrogen, right? A hydrogen was lost, a hydrogen was donated, a proton was donated. So since H2SO4 donates a proton or donates a hydrogen to become HSO4 minus, H2SO4 will be our acid in the reactant side. So as soon as you identify the acid in the reactant side, the product will be the base. Its corresponding product will be the conjugate base. So since this is the acid in our reactants, this will be the conjugate base. Okay, so the acid becomes the conjugate base, and then H2O becomes H3O plus. Okay, so since H2O becomes H3O plus by accepting a hydrogen, by accepting a proton. H2O will be our base in the reactant side, and right away the base in the reactant side will be the conjugate acid in the product side. So this will be the conjugate conjugate acid. Right? So the acid becomes the conjugate base, right? Acid becomes the conjugate base, and the base becomes the conjugate acid. All right? That's all, or that's what the question is going to ask you. If it asks you to identify the conjugate acid base pairs, it's going to be the acid to its corresponding conjugate base, and the base to its corresponding conjugate acid. So you have H2SO4. This is our acid. In the reactant side, its corresponding conjugate base is HSO4 minus. Right? So these are our conjugate acid base pair. Right? So this is one of them. This is the first one. Okay, this is the first one. The second one, the second pair, is going to be between H2O and H3O plus. So this is the second pair of conjugate acids and bases. All right, and just if you read here, HCl, well, this one is for this reaction here, but just basically every acid has a conjugate base and every base has a conjugate acid, right? But just by looking at the formula. I hope this was helpful.